Hello everyone, welcome back to my YouTube channel. In this video, I want to solve Mathematics Past Paper from EJU Year 2018, first session, Course 1. You can check link on the description box below if you want to watch the solution for the other problem, or check my EJU playlist if you want to watch the solution for the other paper. Okay, let's start from number 1. In this question, we have a quadratic function f of x, which is equals to 1 over 4x squared minus 2 minus 1x plus a, where a is a real number. The first question is, the coordinates of the vertex of the graph of y equals to f of x are blah blah blah. So for the first question, we want to find the coordinates of the vertex. If you want to find the coordinate of the vertex of a quadratic function, for the x coordinates, we can use the formula minus b over 2a. b is the coefficient of x, so basically this is our b. And then a is the coefficient of the x squared, which is 1 over 4. So to find the x coordinates of the vertex, we can use formula minus b over 2a. So x is equals to minus b over 2a. This is b, and then 1 over 4 is a. If you substitute into that equation, then you will obtain x equals to minus b minus open bracket 2a minus 1 over 2 times a. a is 1 over 4. And then you can cancel out negative here. And then 2 times half, you will get 1 over 2. 2 times 1 over 4, yeah, I mean. You will get 1 over 2. And then 2a minus 1 divided by 1 over 2, you will get 2 times 2a minus 1, which is 4a minus 2. This is the x coordinates of the vertex. So for letter A and B here, I already got the answer, which is 4 and 2. This is 4 and then this is 2. After we obtain the x coordinates of the vertex, if you want to find the y coordinates of the vertex, just substitute the x coordinates of the vertex into the function. So y coordinates of the vertex is equals to 1 over 4 times 4a minus 2 squared minus 2a minus 1 times x. Our x is 4a minus 2 plus a. By simplifying this expression, I'm pretty sure you will get the y coordinates of the vertex. First of all, I will expand this expression first. So I will get 1 over 4 times 16a squared, 2 times 4a times negative 2, you will get negative 16a plus 4. And then expand this second term, minus open bracket 8a squared minus 4a minus 4a. Of course, you will get minus 8a. And then plus 2. Don't forget plus a at for the last term. And then you can distribute 1 over 4 here into the brackets. Then you will obtain 4a squared minus 4a plus 4. Once again, you need to distribute negative sign here. You will obtain minus 8a squared plus 8a minus 2 plus a. By simplifying this expression, you will obtain negative 4a squared and then negative 4a plus 8a plus 4a, and then 4 minus 2, you got 2, and then plus a. 2 plus a. And then for a plus a, you will get 5a. So this is the y coordinates of the vertex. So for letter C, D, and E, our final answer is 4, 5, and then sorry, I think I made a mistake here because the sign here is negative, but I got the sign here is positive. So if you check my calculation, you can see that 1 over 4 times 4 here is equals to 1, not equals to 4, yeah? So this is 1. So 1 minus 2, you will get minus 1. So my final answer, instead of plus 2, it should be minus 1. So C is 4 and then D is 5. E is equals to 1. This is for the first question. And then for the next question, we want to find the range of A such that the graph and the x-axis intersect at two different points, which is A and B. If you have a quadratic function and then your quadratic function cuts x-axis at two different points, that means the discriminant must be greater than 0. So, since they tells us that our graph cuts x-axis at two different points, I know that the discriminant must be greater than 0. The formula of discriminant is b squared minus 4ac greater than 0. Once again, this is A, and then this is B, and then this last constant term is C. So this is my C. That means b squared minus open bracket 2a minus 1 negative 2a minus 1 square minus 4 times A is 1 over 4, and then times C is A. 1 over 4 times A must be greater than 0. And then if you simplify these inequalities, you will get negative squared here becomes positive, and then 2a minus 1 squared, you will obtain 4a squared minus 4a plus 1 minus 4 times 1 over 4, you will get negative 1. Negative 1 times a, you will obtain minus a greater than 0. That means for a squared minus 5a plus 1 must be greater than 0. If you want to solve an inequality, first of all, you need to find the critical values of this quadratic equation. By vectorize the quadratic equation, you will get for a minus 1, a minus 1 greater than 0. Then the critical value of our quadratic equation here is 1 over 4 and 1. After you got the critical value, you need to draw a number line. I have a number line here, and then I will put this this critical value into the number line. My first critical value is 1 over 4, and then my second critical value is 1. And then we need to check the sign in these three regions. For example, if I want to check the sign in this region, I can substitute 2. Of course, 2 lies on this region. I can substitute 2 into this expression. If you substitute 2 into that expression, your answer is positive number. So the sign here is positive. By using the same method, you can check the sign in this region by substituting, let's say, half to this expression. Then you will get negative number. So the sign here is negative. And then the sign of my last region is positive. The region that I want to take for my answer is the region which is greater than 0. Of course, the region which is greater than 0 is the positive one. So my final answer is a less than 1 over 4 or a greater than 1. So for F and G here, my answer is 1 and 4, and then for H, my answer is 1. 1, 4, and 1. This is the answer for question number 2. And then for the last question, they want us to find the range of A such that the x coordinates of both points A and B in question 2 are greater than or equals to 0 but less than or equals to 6. We want to find the range of A such that the x coordinates on both points A and B in letter 2 greater than or equals to 0 and less than or equals to 6. If you imagine our quadratic function is open upward since the coefficient of the x squared is positive. So if I try to illustrate the graph, I think the graph is something like this. Open upward because the coefficient of x squared is positive. And then if I put an axis, horizontal and vertical axis here, this is y-axis and then this is x-axis. Assume this is 6 and then this is 0. So my quadratic graph should lies in this axis such a way so that the point A and point B are greater than or equals to 0 or less than or equals to 6. So my two intersection point with the x-axis must between 0 until 6. So this is my illustration. From this illustration, you can see that my x coordinates of the vertex must between 0 until 6. Must between 0 until 6. So the first condition that must be satisfied for question number 3 is my x symmetrical or x vertex my x coordinates of the vertex is for a minus 2 must be between 0 until 6. So 0 less than x of vertex less than 6. So 0 less than for a minus 2 less than 6. The x coordinates of the vertex is for a minus 2, yeah. So from this inequality you will get 2 less than 4a less than 8. If you divide all the term by 4, you will get half less than a less than 2. This is the first condition that must be satisfied. And then the next condition is, if you see from this illustration, our value of y when x equals to 0 and our value of y when x is equals to 6 must be greater than or equals to 0. So the next condition that must be satisfied is f of x where x is equals to 0 must greater than or equals to 0. And then f of 6, our value of y when the value of x is equals to 6 is also must greater than or equals to 0. F of 0, we can find f of 0 by substituting x equals to 0 into this expression. Of course, you will get 0 minus 0 plus a. So, a must greater than or equals to 0. And then for this one, just substitute x by 6, you will get 1 over 4 times 6 squared minus 2a minus 1, if I'm not mistaken, times 6, and then plus a must greater than or equals to 0. And then if you simplify this expression, you will get 36 divided by 4, you will get 9 minus 2 times 6, 12a minus 6 plus a greater than or equals to 0. That means 9 minus 12a plus 6 plus a greater than or equals to 0. 9 plus 6 is equals to 15, and then I will move negative 12a to the other side and then plus a to the other side. Then you will obtain 11a minus a, 12a minus a, which is 11a. Therefore, a must less than or equals to 15 over 11. So my second condition that must be satisfied for our graph to be like this is a must greater than 0 but less than or equals to 15 over 11. So from this range of a, my second condition is 0 less than or equals to a less than or equals to 15 over 11. And then, of course, we have the third condition, which is the condition that is satisfied in question number 2, which is a less than 1 over 4 and a greater than 1. A less than 1 over 4 or a greater than 1. These are three conditions that must be satisfied for our value of a so that the x-coordinates of both point A and B in question number 2 is greater than or equals to 0 and less than or equals to 6. By finding the intersection of these three conditions, I think we will obtain the final answer. If I want to find the intersection, I can use a new number line and then just draw the inequality one by one. First of all, half less than A less than 2, I will assume this is half, and then this is 2, so this is our first condition. For my second condition, 0 less than or equals to A less than or equals to 15 over 11. If I draw it on the number line, let's assume this is 0 and then 15 over 11 somewhere here. This is my second condition. And then our last condition is A less than 1 over 4. 1 over 4 is something here, somewhere here I mean. A less than 1 over 4. And then A greater than 1. 1 somewhere here. From this number line, you can deduce that the region where the value of A satisfy all these three inequalities is somewhere here. So my solution or my range of A is from 1 until 15 over 11 inclusive. So my final answer for question number 3 is 1 less than A less than or equals to 15 over 11. So letter I is 1, J and K is 15, and then L and M is 11. Okay, this is the solution for question number 1, which is the first question from EJU Mathematics 2018, first session, course 1. I think that's it for this video. Thank you for watching this video till the end. You can watch the solution for the next question by checking the link on the description box below. Thank you once again and bye-bye.